Moes Youssef, an associate professor, including 3 assistant professors, published a paper called Simulation and Design of a Single-Phase Inverter with a digital PWM issued by an Arduino board. Now the main title of our PBL will be about the THD level effect on the output waveform. Let's have a look at the FILA table. This table consists of all the facts, which is the facts we found in the problem itself. Then we have the ideas generated to manage the problem. Then we have the learning issues, which are the topics we need to learn before we manage the problem. And finally, the action plan, which is a list of plan to show how, what, and where we seek all of this information. So all of this will be clearly elaborated as we move along with the slides. First up will be the facts or problem statement. So the output waveform of a square wave inverter has a high total harmonic distortion or high THD level. Okay, so the THD refers to the unwanted harmonic frequencies in the waveform itself. So this will spark some of the problems that I will mention now. So the high THD level results in the waveform losing its characteristic, which is the square shape itself. It becomes more irregular with the rounded edges and jagged peaks as the harmonics introduce additional variations to the waveform. The THDU, or otherwise known as the total harmonic distortion of voltage, is around 48.3%. It indicates that the waveform of the voltage is significantly distorted. This is because the harmonics, which are the additional frequencies that are not present in the original signal, are adding to the waveform itself. The harmonics are causing the waveform to lose its characteristic, which is the square shape characteristic, and it becomes irregular with rounded edge. Okay, the THDI, otherwise known as the total harmonic distortion of current, which is about 12.2%, which is also relatively high, but it is not as high as the THDU. This is because the harmonics are giving a greater impact on the voltage waveform than they are on the current waveform. The high THD levels in this case are likely due to the fact that it uses nonlinear loads such as power electronic devices. These devices can introduce harmonics into the electrical system, which can cause problems such as increased losses, overheating, and interference with other devices. Okay, now let's have a look at the ideas. So, for the first idea, no filtering technique is used to filter the output waveform of the inverter to reduce the THD levels. Although this filter is not introduced in the research paper, but we included it as one of the main factors that can affect the THD levels. So normally a filter is a device that can be used to remove unwanted frequencies from the signal. In the case of an inverter, a filter can be used to remove harmonics from the output waveform. This can improve the quality of the output waveform and reduce the amount of noise that it is generated. So for the second idea would be no modulation techniques that is used to decrease the total harmonic distortion of load current to make the harmonics to be at a high frequency, allowing easier filtering. So even though the research paper, it does introduce some of the modulation techniques, but it can be one of the main issues that can affect the THD levels. So there are a number of modulation techniques that can be used to reduce the THD levels of the load current. So these techniques work by distributing the harmonics more evenly across the load current waveform. This can make it easier to filter out the harmonics as they will be at a higher frequency. So these are the learning issues, so feel free to pause and have a look. So for the first learning issues would be what is the working principle of a single phase square wave inverter? So a single phase square wave inverter is a device that can convert DC power into AC power. It uses a technique called pulse width modulation or PWM to produce a square waveform output. So in this case, the Arduino board controls the PWM signal, which determines the output voltage and frequency. The output of the inverter is then filtered to remove unwanted harmonics. Thus, in other words, the inverter takes DC power from a battery or other source and converts it into AC power that can be used to power devices like lights and motors. So the Arduino board helps to control the output voltage and frequency of the inverter. And then the filter removes unwanted harmonics from the output waveform. So let's have a look at the second learning issues. So what is the filtering technique that is used to reduce THD? So the filtering technique that is most commonly used to reduce THD in power electronic system including inverters, is known as harmonic filtering or passive filtering. So harmonic filters are used to reduce THD in power electronic system, and there are two main types of harmonic filters, both passive and active. So passive harmonic filters uses passive components such as inductors and capacitors to attenuate the harmonics, while active harmonics filters uses active components such as IGBTs and MOSFET to actively cancel out the harmonics. So as for the third learning issues, what is the modulation technique that is used to reduce harmonic distortion? For this case, we will specifically talk about the SPWM and SHE. So SPWM and SHE are two modulation techniques that is used to reduce harmonic distortion in power electronic systems. So SPWM, which is on the left side, the left graph, it generates a sinusoidal waveform by comparing a high frequency carrier signal with a reference sinusoidal waveform. However, for SHE, which is on the right side, it eliminates specific harmonics from the output waveform by adjusting the switching angles of the inverter power devices. As for the final learning issues, let's have a look at what is the best modulation techniques that is used to reduce harmonic distortion and improving the quality of the waveform. So there's two modulation techniques, SPWM and SHE. Both also offers a good harmonic performance. However, SHE is much better at giving out a much better performance in terms of harmonic. However, SHE is more complex and SPWM is more simple to implement. SHE has a higher switching losses compared to SPWM, and the applications for SHE is more specific while SPWM is more generally used. In general, SHE is a better modulation technique for application where low THD is important. However, SPWM is a better modulation technique for applications where simplicity and cost are important. Okay, to answer this question, what is the best way to improve SPWM inverter? So there are three main points. First of all, using a higher switching frequency. So if you use a higher switching frequency, the inverter switches between the on and off states. A higher switching frequency will reduce the amount of time that the harmonics have to build up in the waveform, in the output waveform itself. So this will result in a lower THD level. Okay, for the second point, using a filter. So a filter can be used to remove the harmonics from the output waveform, leaving a pure sine wave. There are a number of different types of filter that can be used, including low pass filter, band pass filters. So the type of filters that is best for a particular application will depend on the harmonics that are present in the output waveform. So for the third point, using a high quality power supply. So it will reduce the noise and interference that can corrupt the output waveform. This will also help to reduce the THD levels. Let's have a look at the action plan. Now, based on the article from International Journal of Engineering and Technical Research titled Simulation and Design of a Single-Phase Inverter with Digital PWM issued by an Arduino board. So, to achieve a better quality of waveform, SPWM and SHE technique can be both used to reduce the harmonic distortion. So, we can use SHE for a better quality for output waveform. But if you want to save cost, we can use SPWM. Both also can be used to achieve the required output waveform by reducing the THD levels. So let's have a look at the final solution for our problem-based learning. So we started off by analyzing the THD levels of the output waveform uh, and how it affects the output waveform. As we can see from the research paper, both SHE and SPWM techniques can be used to reduce the harmonic distortion. Both has its own pros and cons that needs to be taken into consideration before choosing either one of the techniques. So let's have a look at the filters. So filter is a device that can be used to remove unwanted frequencies from a signal. So a filter can be used to remove harmonics from the output waveform. Even though in this research paper it doesn't talk much about the filters, but we included it into our video presentation because it is actually one of the most important factors that can affect the output waveform. Because because we want to improve the quality of the output waveform and reduce the amount of noise that is generated. This is why a filter is really important in terms of removing the harmonics from the output waveform. Okay, thank you. And that's all for this video presentation.